And number 4, don't get fooled by using any fancy formulas, no NCRs, nothing like that. They're just saying, look at this chart and tell me the probability that the person is a boy. How many boys are there? How many people are there? You're done with that problem. 400 out of 790. That's it. Leave it like that. I don't need a decimal. You don't have to reduce it. That's fine. B, the probability the person plans to vote for John. So how many total yeses do we have? 430. Total yeses divided by how many total people? 790. Fix my 3. 430 out of 790. That's it. Move on. Don't overthink it. C, given the person plans to vote for John, right away, you now only focus on the people voting for John. Given the person plans to vote for him, how many are boys? Out of the 430, so now your denominator is 430. How many are boys? 250. 250 out of 430. This would be the probability that the person is a boy, given that they are a yes vote. Just do 250 over 430. That's it. Because this is the probability of both, that they're voting for him and they're a boy, divided by the number of yeses. Yes. Okay, that's good. D. Again, this is given the person is a girl. So now, what should I black out up here? Given the person is a girl, what don't we need? Do we even need the totals? Given the person is a girl, this is D. Given the person is a girl, out of the 390 girls, how many are yeses? 180. That's D. Okay? Now E is where we do the test for independence. Is voting for John and being a boy, are those two events independent? Here's what you have to do for part E. To check whether boy and yes, I'm voting for him are independent. You check the probability that you pick a boy against the probability boy given yes. This is the test for independence. You check the probability of one thing against the probability of that thing given the other. So I believe we already calculated the first thing, probability of boy. Wasn't it right here in green? 400 out of 790. Can I get that as a decimal, please, to the nearest hundredths? 0.51. Does this tell you that 51% of the students are boys? Yes. Now, we're going to see, out of the people voting yes, out of the kids voting yes, which is how many? 430. How many of those are boys? 250. Can you give me this as a decimal? 0.58. So would it be correct for me to say 58% of the yes votes are boys? Right? So, there's a higher percent of the yes votes boys versus a higher percent of the total population boys. Yes. So does that probability change when you limit the group? Yes, the probabilities are different. Therefore, these two things are dependent. They're not independent. E is dependent. bigger percent of the yes votes are boys than the percent of the people that are boys. So does it seem like more boys are going to vote for this kid than are boys total? Okay, so those two things are dependent. The probability of one depends on the other. That's number 4.